Here are the answers for the day 4 bell work. Question A. We need a 0.1 molar silver nitrate solution for a lab experiment. How many moles of silver nitrate would need to be dissolved in 500 milliliters of water to make this solution? Here's the formula that is used for problems involving concentration of solutions using molarity. In this formula, the letter M is representing the word molarity. When you find an answer for this, the little label you'll use will be a capital M and the word will be molar. The letter N is representing number of moles of solute. It's how many moles of the particles that are dissolved into the liquid solvent. The letter V is representing volume in liters. And it's very important that you recognize that you have to use a value that's in liters when you use this formula. It's just like when we were doing those gas formulas and we would fill in a temperature for the capital T, and we always had to use Kelvin. We could not use Celsius. It's the same idea here. When we fill in a value for the volume, it has to be a number that's in liters. Okay, we're ready to use this formula. We know the molarity of the solution that we want for our chemistry lab, 0.1 molar. Fill that in for the letter M. What we're asked is, how many moles? So the letter N is going to be our unknown variable. Then we're given the volume of liquid that we want to end up with, 500 milliliters. But when we fill it in, it has to be in liters. So how many liters is 500 milliliters? That's half of a liter. Or if you do a decimal, it's 0.5. Because there's 1,000 milliliters in 1 liter. So 500 milliliters would be half of a liter. This creates an equation. The unknown is the N. It looks like we can multiply by the 0.5 to get the N alone. The result is 0.05, and the letter N was representing moles. So that's our label. So let's say that we're going to do a chemistry experiment tomorrow. And instead of me making up the solutions that we need, I had students make up the solutions that we need. Those students would have to use 0.05 moles of the silver nitrate powder from the supply room and stir that into 500 milliliters of water in a container. Next, the second question. We used 750 milliliters of 0.2 molar copper sulfate solution in a lab. How many grams of copper sulfate would need to be dissolved in water to make this solution? And as a hint, let's first figure out how many moles of copper sulfate are needed and then get the answer in grams. This problem involves the concentration of a solution where molarity is used for that concentration. So let's use the molarity formula. M equals N divided by V. The molarity is given. Let's put in 0.2 for the capital M. The number of moles is what we don't know. And the volume is 750 milliliters. But we have to use a number that's in liters. So 750 milliliters is the same thing as 0.750 liters. To change milliliters to liters, you divide by 1,000. A quick way to do that is to move the decimal 3 spots to the left. To solve this for N, it looks like we need to multiply the 0.75 to the other side. And the result is 0.15 moles. Now we're not done because the question asks how many grams of copper sulfate are needed. And all we have figured out is we need 0.15 moles of copper sulfate. So in the next step, let's do a conversion. 0.15 moles times, draw the line. Down here we'll put 1 mole. Up in the top we'll put grams. And then as our number right here, we need the molar mass of copper sulfate. We've done this kind of work a lot this year. This is where you use the periodic table and you look up the mass for the copper, you look up the mass for the sulfur, and you look up the mass for 4 oxygens. And you add that all up, and that'll be the total mass of 1 mole of copper sulfate. That value is 159.602. And that mass for 1 mole of copper sulfate needs to get multiplied by the fact that we only have 0.15 moles. The answer is 23.94. grams. So let's say we were doing a lab experiment tomorrow and I wanted students in this class to get the solution ready that we're going to use. Those students would need to weigh out 23.94 grams of the blue copper sulfate powder and then stir that into 750 milliliters of distilled water.